Good evening, everyone. I, Ananta Kantray, on behalf of IEEE-IISc Communications Society chapter, welcome you all on the talk series titled Careers in Embedded Design, an Insider Peek. Today, we have with us two speakers from embedded industry. They will give us an insight to the current trends in this area. I hope you will all have an enriching experience. So, without further delay, let's jump to the talk. Yeah, so our first talk for today is titled Elements of Embedded Hardware Design. And our first speaker for today is Mr. Manish Gunnam. Before starting, I would like to give a brief introduction of Mahesh. Mahesh is a platform hardware design engineer at Intel with more than 8 years of total experience in hardware design. His expertise is mainly in systems hardware design, high speed board design, validation test setups, spanning most variety of applications and interfaces. Reads a lot and loves solving problems. So, over to you, Mahesh.
Hey, hi. Thank you for the quick intro. Am I audible there?
Yes, you are.
Okay, thank you. Uh, yeah, I'm really excited to be here, and I definitely feel this is a greatest opportunity. Um, yeah, let me just present my screen. Can someone confirm the screen is visible?
Yes, it's visible.
Hey, okay, thank you. Yeah, so today I wanna talk about elements of hardware design. How do we, go about it? First, a few words about me. Uh, yeah, as this talk is about the embedded systems, I think uh, just to give a background of me, now I have been in embedded system studies diploma till the masters. Okay, and whole of my career, I have been a hardware design engineer. I have worked on a couple of applications like defense systems and then medical endoscopic systems, and then I worked on various validation setups, IoT devices, and most recently I've been with Intel and been working on client systems. Basically, if you have joined with a computer, uh, right, and I worked on most recent generations of Intel processors. And then if you guys know about Thunderbolt or USB 4, which is a trending interface in the laptop segment, uh, I've been with that interface. It's one of my favorite, and I'm also a signal integrity uh, encourager, or what you call as the evangelist, right? So I love signal integrity. I love the challenges, and I keep encouraging my team about signal integrity. And yeah, and every problem is an opportunity to innovate, right? That's about me. Then what's about the talk? Okay, so we'll go today about my talk. Um, just give me a minute. Uh, keep my timer on so it can be on time. Yeah. Yes. So we will see the overview of hardware. Where is hardware? And when I'll cover only the basics. I don't want to get into the deep given the time. And then we'll see where are the hard electronics and how do we design anything. A simple four-step approach to any design. And then we see a couple of fundamental questions to start in any hardware design. Okay. And then we'll see most common categories of circuits. If you are someone who's looking into get into the hardware engineering, now what are some circuits that are most commonly, most likely that you're going to be looking at? And then I'll also show a couple of tools that we use in the industry. Then I can also see what subjects we need to focus to be an expert and to have a successful career in hardware engineering. Okay, to start with, right? Unfortunately, I can't see the screen, but what comes to your mind when we say electronics, right? Feel free to unmute and speak. What usually comes to your mind when you say electronics? Right? I mean, electronics is a very generic term, and it's most commonly used. Uh, what comes to your mind? Any takes? Okay, so I hope you have joined with a laptop or a mobile, if not, and I hope you are using a headset. And I hope you are using a mobile. So these are part of common consumer electronics, right? So you use power bank, cameras, projectors, keyboards, right? So most of the people are aware of these electronics. These are the day-to-day life, we live with. But I also want to quickly walk through, where all the electronics go into, or the what applications of the electronics, right? So if you look at the car, right? So car is most, a lot of the bomb in the car is electronics. So your body electronics, right? And then your powertrain, and then your advanced driver assistance systems, and then your infotainment systems in the car. Uh, Everything is electronics, right? So you press a button and the motor rotates and brings down your glass, right? Uh, and then your medical equipment, which are basically, they should be very safety. You go to a hospital, you come across a lot of electronics. So there is a branch of separate. It's called biomedical electronics, which deals with a lot of human safety, and but the fundamentals are the same, right? So what we have is the same. It's a basic electronics, right? And if you look into the cockpit, right? So everything there is again electronics. Okay, so uh, coming to your radar, right? How do you trace and range and locate to your control systems and the communication systems? So a lot goes in there. And your industrial electronic applications of manufacturing industry, uh, and then you have home automations. These days, if you uh, buy a smart home, right? So you come with a digital lock, and then you have digital alarming systems and the camera systems and the smoke detectors and safety. No, and then there are robotics that clean up your house. Uh, there are a lot of things. Just giving an intro. How many of you see this image? This has come up recently in the Republic Day. Akash. How many of you know about Akash? Uh, so Akash is our indigenously developed missile, right? So electronics are there in our defense system, right? So if you have keenly observed, our Indian government allocates a lot of budget for our defense electronics and defense systems to be developed, and it invests a lot of money into that. So if you even look at any warfare system, right, and most of these electronics. So I've been part of some of these developments. And then also you have a cloud, right? So where everything runs these days, and which are very high computing and very high intensive workloads. And then he needs a huge amount of space, as well as uh, processing power, and then it consumes a lot of power, but it gives you the flexibility of having everything in the cloud, right? So what I say is electronics are everywhere. Okay, so uh, so uh, what is something common about everything is the hardware, right? Let's say you are doing any technology and it's running, right? Let's say you have a lot of software and you have AI, ML, everything, right? Whatnot. Everything that exists is has to run on a hardware, right? So there should be somewhere a system, a processor, or to be in depth, right? ALU doing your computations, solving your maths, and doing your problems, so that the people somewhere else can have that services provided, right? Uh, so how do we actually design anything? Okay, so let's look at common. mm, what is most common is the house construction, right? So you have a concept, and then you talk to your family and gather requirements. How many rooms I want, or how big it should be, a bedroom or whatever. I'm just giving an example. And then you get the floor plan, and then you construct it. Okay, just applying to one common application. Just apply to any application that we design, like a smartphone or a watch or whatnot, tablet or anything, or some applications that we saw. Actually starts with the concept, and then you gather the requirements in detail. Okay, what has to be what, what should be the form factor, how it should look like, what it should do, and then you engineer it, right? So you get into the technicalities of it, and then you draw. We'll get into that later. And then the next thing is you manufacture it, and then you have it tangible product in your hand, right? So that's what basically gives you. So the first three steps is the paperwork, but the last step is where you actually have it in your hand. So if you see the first two steps, right? So if you observe, so this is called a product definition and the architecture, right? Um, and then the third thing is the engineering, right? So whether you do what, uh, if you are an electronics engineer, you'll be doing electronics. If you are a civil, you'll be doing a floor plan and the different civil engineering, and then the construction, right? So that's where the manufacturing industry comes in. Like if you see, the India is investing in, giving incentives for the manufacturing industry to boom in India. So that's where it's actually. Let me just use a pointer. Yeah. So this is where actually we have going to be in the future. But if you have done an engineering, so you typically land here. I mean, right? So because the first two is like mostly like your product definition into your sales and your consumer reports and researches, and then architects usually be of high experience. But if a fresher looking into getting into this industry, probably best way to start is this. Okay. So what? So we are all electronics background, I guess. That's my assumption, and we all have done engineering. So what is engineering, right? So what fundamentally makes an engineer is, art of asking questions. I mean the good ones, right? So how do I ask questions? So let's say now I have to design. Let's say we have looked at a watch, right, or any other application. So what are some fundamental questions to be asked in terms of the hardware when we have to design a hardware, right? So the first question, obviously, that is a central to hardware is a processing source. So what is the process? Like most of you have seen this Arduino boards. No, you have a Atmel or the microcontroller, which is the most common in most of the embedded systems and IoTs, right? IoT devices. That is the most common, but that's not all about electronics, right? So you have general purpose processors, like the things that goes into your desktops and the laptops and into various boxes, right? These are like they do any job. Depends on what software you install. And then there are field programmable grid arrays. They call FPGAs. So which means it's a black box, and you program the way the digital circuit has to work. So you don't predefine it. You can program the way it has to work. So those are the beauties of FPGA if you have never heard about it. So some companies that manufacture is Xilinx and Intel and Lattice. So it's just for your introduction of these devices. And then you have a processors which are server grade, right? So on a higher scale, if you see the cloud, as we have seen, data centers, so huge processing. And okay, so I have this processor. Let's say I have figured out what the process is. Then where my power come from? Okay, so should I be a battery powered? Should I be a I have a adapter connected or always connected like a data centers, right? So the key question is the second key question I would categorize is the power, right? So from where my power is coming. So knowing that is critical, right? So you would have seen some batteries, and then the memory, right? So even if you see the scale of electronics, let's say the simplest form of it is a embedded system. So you need to store your program, right? And also every CPU needs memory so that it can process, right? So what kind of memory that I'm going to use, right? So I have to figure it out at start. Know what kind of application storage I need, the data storage and processing store memory, right? Uh, so these are some fundamentals of memory. And how does it interact with me? Like what kind of sensors it has? Does it has a mic or no? Will it rotate some motor or no? Maybe it has some screen I can see, and maybe it can display some data, or maybe it can have an interface like USB or HDMI. Right? These are all your interfaces, some common interfaces that we interact with electronic equipment. Maybe it has a speaker and it can beep some sound. So these are some fundamental questions to keep it in mind when we have a hardware design. So I would like to walk through some broad categories of circuits, right? So like what are the some common circuits that we have come across? Okay, you have already studied about transistor. So when it comes to the digital circuits, right? So what I need to know is what is my logic 1, what is my logic 0. Okay, if I know that, uh, that's mostly it. Okay, and the transistor in digital circuits mostly works either in cutoff state or a saturation. What I mean is it is either on or is off. Okay, so that is the simplest form of electronics if you're working with the transistor. So those are digital circuits. Okay, so you have some digital logics, whatever you studied. Uh, and then there are interconnects, right? So how do I interconnect different uh, ICs or different peripherals on the motherboard or on the hardware, right? So some common protocols. You would have heard I2C. How many? I think I'm most certain that all of you would have come across I2C and SPI, which are some basic interfaces. There are a lot of complicated interfaces like LVDS and CML, current mode logic, and others, HDMI, DP, whatever your interface is. Every interface works with a protocol. Okay, so how do I communicate? How do I transfer data? How do I synchronize? Right. So all these aspects are called out in the protocol. And then the other category of circuits fall under the power delivery, which is another major part of the hardware design. Right? How I convert the one voltage into other voltage, because my processors and the controllers or whatever the digital circuits they all work at different levels, different voltages, like 3v3, 3.3 volts, 1.5 volts, 1.8 volts, some 5 volt, some 1 volt circuits, right? So, but your battery doesn't give all those all those voltages, right? So you have to convert. Let's say I am working with a wall supply, so I need to down convert. So you would have seen this bridge rectifier, right? So which is basically converting AC to DC so that you can connect. I'm not saying that this is all. This is just to start with, right? So there are a lot of complicated buck circuits, right? And the boost regulators, and then the battery. How do I manage battery charging and discharging, right? And battery is something which is prone to explode and safety related, right? So how do I handle? So there are ICs, uh, the circuits that come under that. And then the clock circuits, right? So how do I, so let's say clock is a heartbeat of electronics, right? So let's say you have a power and you have a processor, but don't have a clock, nothing is going to run. So because everything that is working in synchronous with your clock, right? So and why do we call it a clock? Because clock is a reference of time, and every signal, right, every bit, either maybe 0 or a 1 is reference to a clock. So some clock circuits you will be seeing, some PLL, phase lock loop. Some would have heard about it. How do I distribute buffer? So like split it. So you would have seen some oscillation circuits, right? So you would have come across crystal in your studies and the oscillators, so different sort of oscillators, and I'm sure certainly you have done some experiments with generating some frequencies, right? So those are the other category of circuits that come under. And then what else? Your RF and analog circuits, right? So far we have only seen the digital part of the circuits, but there are interfaces like your Wi-Fi and your Bluetooth, right? These are all not digital circuits. These are purely your RF, right? So your analog signals, and even your audio codecs, right? So they are analog. So you are hearing it. Right? It's not your digital 0 and 1. So here is where the transistor works in your linear region. And these are some of the most complicated and fine and hard to debug circuits, I would call, right? So these are your amplifiers, attenuators. So all those circuits that you studied are actually comes in these applications of RF and analog front end circuits. And then you would have known about some user interfaces, right? So let's go. And then some of the other aspects of thermals, right? Like I have a IC, you have seen the IC semiconductor, and then and every semiconductor generates the heat, right? So how do we dissipate that heat, and how do I transfer that heat? How do I take it out of the system? So there's another challenge, or the basic element to the hardware design is your thermal management. Okay, so do I need to have a heat sink, or do I need to have a fan, or one fan or two fans? How do I do this? Right. So let's say if you have worked with the Arduino, there is no heat sink. But if you have gone to a Raspberry Pi and you're loading a lot of application, you would have seen it ships along with a small heat sink, aluminum heat sink. So that's where you get complicated, right? So how do you manage the heat? And if you've seen in your laptops, right? So the fan blowing up sometimes when you're gaming or running some heavy application. So that is your thermal management aspects of it. And then you will see some protection circuits like over voltage protection, and then ESD, and there are the other circuits. So these are the basic elements I'm talking about. And then signal integrity is another challenge. The signal integrity is nothing but what is your analog behavior of your digital signal, right? How it's actually, when I say digital, it's a 0 and 1, but it's on the on the actual reality, it is not 0 and 1, right? It is a voltage, and it has an amplitude at every instant of time. So how do I actually handle it, right? So how do I know if the signal is not in the threshold? I don't know whether it is a 0 or a 1, and your signal can fail, right? Your communication can fail. So, so the major challenge that comes in hardware design is signal integrity, and uh, it's a huge. I just want to touch upon. Having looked at some categories, uh, let's see how this look in reality. Let's take a, Apple motherboard. Let me just Okay, so what we have here is a PMIC. What is this does is it generates the power. Like I said, DC-DC mostly because we work with a battery. And then what you have is another PMIC, right? So again, this is another power, right? So this supplies the power for your processor. So you see how important is the power, right? And again, you see there is another PMIC. PMIC is nothing but your power management IC, which includes a lot of LDOs and the SMPS, and the circuits that generates different voltages needed for the device. And then what you have is you see here there is another power management IC, and then you have your WLAN device. So this is where your RF analog circuits come into picture, right? As I talked about, these are your analog circuits. So what you have is the audio codec. Again, this we talked about. This is another form of a combination of digital and analog circuits, uh, right? And then you have uh, this is your port. This is again falls under the power. Now, how do you deliver the power on the Type C? And then you have some RF front end, right? So this is your basically your Bluetooth and Wi-Fi and how the stuff works, all the connectivity related circuits, and you have a major part of it is a digital processor, right? So uh, yeah, so we'll look at the one more thing. I'm I think running out of time. If you see, right, as I talked about, you have your memory circuits, and then your power supply. You see here, power delivery circuits, and then so again there is a power delivery circuit here that is needed for this processor here, uh, and again there is so if you see here the clock synthesis, right? So there's there is some circuit that delivers the clock, that generates the clock needed for the processor, as I talked, right? So nothing works without the clock. And again, you see the power again. If you see, these are all power circuits, right? And then you have a battery management circuits, as we talked about. So this also falls under the power. How do you boost and buck convert battery voltage into different voltages? And then you have what you have here is a RF circuit, right? So you have your analog circuit comes in the your WLAN and your Wi-Fi, uh, the rest of the other circuits. And then there are some digital logics. So basically, these are all the categories of circuits. If one has to master the hardware design, has to focus on. Okay. I'll just quickly take 1 or 2 minutes. How do we do this? Okay. So any design. So you have a block diagram on the spec, and then you enter it into the schematic tools. Either your app, so some tools called from Cadence, there's called EDA tools. Then you check up whether your circuit works well, you simulate it, whether or not expected behavior. And then what you do is you import that netlist into your CAD layout design tools, and then you physically place your components, right? Your every this IC and the resistor, capacitor, and the inductor, what all components that you have in your design, you place it manually and connect them on the layout, right? And then there are tools which can do a thermal simulation, how much is your heat and whether your signal is okay. And then you finally of fact send it to the manufacturer. So once we send it to the manufacturing, you obviously test it, and that is a separate topic. But this is how your overall any hardware design start to end looks like. Okay. Okay, what subject should I focus? So circuit theory, as I talked about, everything is a circuit. You would have seen lot of circuits, resistors, capacitors, and inductors, right? And then you need to do well with your digital logic design, because even how experienced you are, you will be still coming to the basics and scratching your head and how to solve between your 0 and 1. Okay. And then the CMOS FET. So when you come to the power electronics and power conversions, your FET and in-depth physics is going to help you a lot. And in the all electronic components, as I said, especially your power delivery and how you convert the voltages. Uh, and then your field theory, it's another essential for layout design. Uh, how actually a signal transmits from one IC to another IC, or even from one equipment to another equipment. How is exactly the electric field and the magnetic field look like, and how is the current field show up in a layout, right? What are these effects and the side effects? And then if you have some mechanical background, it's good so that you can understand the form factor and thermal designs. And obviously you need to have some touch in the software architectures. Okay, think I'm pretty much done. Just want to close with this. Um, as I grow in my career and getting some maturity, uh, so what makes you a good engineer, right? So what makes a good design? Let's say you like Apple design over a Dell design. Okay. So the good design is nothing but a good trade-off, right? The correct trade-off that is made at every aspect of the design. And a good engineer is nothing but a one who can make that good decisions. And the experience is what helps, in precisely making your decision. Okay, that's all I have. Thank you. Any
Thank you,
questions
Mahesh.
or on
Yeah,
any of the slide? I can spend a minute. Uh,
the participants can unmute their mic and ask their questions, or they can even post those in the chat. So there
okay.
is one question. Yeah, okay.
Yeah.
You have seen it. Okay, fine.
No, sorry, I have not seen. Can you read it?
Okay. Yeah, so there is this question in the chat. Will photonics play a role in hardware design soon?
Sorry, I didn't get. Can you repeat, please?
It's will photonics play a role in hardware design soon?
Yes. So photonics, actually, I have not touched upon it in this talk. If you go into the data centers and the cloud infrastructures, right? Uh, so basically, how do you transfer these gigas of data from the switch to switch, right? So there, photonics plays a major role. I mean, so like 40 Gbps per second. Right? So that kind of huge bandwidth. Uh, so photonics is where I don't know if you have heard about SFF. There are these modules that come up, which basically the fundamentals of photonics. Photonics plays a lot of role, um, and but it's a specific application that is in the data center segments.
Thank you. So we'll have more questions after both our talks. So stay tuned for those questions, and I hope Mahesh you also stay, and then we'll have more
Yeah,
of a longer question and answer session.
sure.